then obviously put the hot air you sucked out of the
Hi, I'm Rod Morris from the Sangosse. We specialise in adjuvants, water transitioners, slug pellets. Here today we have our demonstration unit called Spraywise. The main purpose of the unit is to demonstrate the wetting agents around our adjuvants. In particular, we can show off the way they spread across the leaf and able to maximise that technology, especially in use with herbicides in particular. We also have the benefit of a wind tunnel built into this unit as well, which is able to demonstrate the drift retardant properties around some of our products, like Validate, for instance. So this is an example of a test that we do within the unit, where it's showing an adjuvant being used and not being used. So you can see on the right-hand side this bean plant, where the droplets have not been spreading that well, and the droplets deposition is not as good as we see on the left-hand side, where we have utilised an adjuvant and the spread has gone further along the leaf, making sure that we are maximising the coverage of a herbicide on this particular target.
It's basically a demonstration piece of equipment. It's not a research tool, but it's still very, very accurate and is able to display a number of things. We can look at the effects of nozzles, we can look at the effects of air causing drift, and in fact we've even got a rain simulation program on this that we can use to look at rain fastness of materials on the surfaces. It's capable of operating at wind speeds up to 12 miles per hour, and the boom, it's actually got 4 booms within the linear spray rig, and they can cross that area at up to 10 miles an hour. So it can simulate what you do in the field fairly well. We are dressed in white coats, not because we're particularly scientific, but because we're using a fluorescent dye in the machine. The fluorescent dye means that we will glow blue when we leave this building and ultraviolet light hits us, so we're able to take our coats off. No pesticides will be used. You are perfectly safe. We're going to start off with the drift demonstration. We're using an 03 flat fan nozzle. Wind speed is going to be 6 miles per hour. For those of you who are metricated, and I think looking at you, a lot of you will be metricated, that's 9.6 kilometers per hour. Pressure is going to be 30 psi, and again, for those metricated people, 2 bar. And the wind will be operating for 5 seconds. And we will be looking to see how the spray pattern which comes down from the nozzles is blown across onto the water sensitive paper behind on the sort of the screen back there. So you can see now the nozzles coming across. The pressure has been built up using an electric pump in the back of the machine. It's now spraying. The fan is on. You can see hopefully that there is quite a bit of drift in there. We will now have a look and see what in fact the water has done to the water sensitive paper. Okay, this is about 20 centimeters below the nozzle, 40 centimeters and 60 centimeters. So this is the sort of that where you're going to get most drift, and as you can see, the water sensitive paper has been totally saturated with drift. At the 40 centimeter level, you've got probably 35% of the paper covered, and when you go up to the 20 centimeters, it's probably only about 10-15%. So that's what you would get with a typical flat fan nozzle operating under the sort of the 6 miles per hour wind speed. Here we now go with the conditions are exactly the same, only we've added a product called Validate at 0.25%, and we will look to see whether that has any impact on the amount of drift that we get. Right. Well, this certainly hasn't got as much deposit on it as the water alone. You can actually see quite a lot of the water-sensitive paper. We've probably got only 70-65% of it covered with the spray, as opposed to 100%. Here we're probably down at about 10% maximum, and up at the top virtually nothing whatsoever. You can certainly come and have a look at this. Drift reduction is just one of the properties which this material has. It's not its main property. Basically, the product Validate is an adjuvant. It gives you improved coverage over the target. It's got anti-bounce properties for the droplets. It has adhesive properties for the droplets, which gives you high levels of retention. And more importantly, it gives a consistent droplet size. Now that's important, because what you're wanting, when you set your nozzles in the field so that they are basically giving you the best coverage at the height of the target, that's reliant upon the fact that the droplets that are coming out of the nozzle are uniform in size to get the maximum number on the target. And that's one of the things that Validate will give you. In addition, it's both a penetrant, which allows the spray, if it's a systemic material, to pass through the cuticle of the plant, and a translocating agent. It basically covers the active ingredient with a liposome. And a liposome is something that the plant normally contains. It has liposomes, they move through the liposomal pathways within the plant, which allows things to move to areas that they otherwise would not be able to get to. It's the same technology that the drug manufacturers use with a lot of their materials, to carry medicines to parts of the body that otherwise wouldn't receive them because the body wouldn't accept them. The targets we're setting up are bean leaf and cereal, ear and flag leaf. I'm going to put those on the bench there, which has been set at 50 centimetre height below the nozzle. Pressure's building up to the right pressure. When it's at the right pressure, that's it. Yes. So that was 7.4 miles per hour. It looks a lot faster, but that's principally because you're only seeing it through a very short window. Photos of the two targets. You've got the bean here. You can see they've got some beans are relatively easy to hit. So you've got these sort of fairly large blotches on the leaf where the water droplets with the dye have landed. But here you've got the leaf. Here the ear, and you can see where the fluorescence spray has gone. Some of it is sort of resting on the sort of the ear, the outside of the ear, but it's principally just a group of dots rather than good cover. I think here immediately you can see the droplet size is much larger. Yes, better coverage of the leaf, and also of the ear. You've got much greater deposits have remained on the ear than you got with the water alone. So it shows the benefit of having the wetting agent within the formulation. That's the water. You'll notice that with time you do get some run down the leaf. Yeah. And here you've got the blank pesticide formulation, which has put a lot more pesticide on the target. We've now added an organosilicon super wet. So this is something which reduces the surface tension far lower than you would get with the pesticide formulation. What we've got here with the organosilicon is, you notice how you've got these lines of spray coverage as it started to run over the leaf surface. And we move up towards the ear. And here in particular, you can see that it's really sort of swept into the ear. It's giving you much better coverage of the difficult to wet spaces within the ear. And you've also on this on the flag leaf, you've got these lines of coverage which have come from the inclusion of the organosilicate. Because the concentration in the spray droplets is reduced, it's actually kinder to the cuticle of the plant. You don't get the scorch that perhaps you would get applying a pesticide formulation on its own. Reason that the material is not formulated in the pesticide is it's unstable for prolonged periods of time in association with water. This is why you have to basically add it to the spray tank before you go ahead and use it. There's the water, and here you have the silhouette, and literally it's covered the entire surface of the leaf. That's very typical of what you get with it. As you go through the crop spraying something with silhouette, you get a sheen over the entire crop because of this very high level of coverage that you get. The other advantage, of course, with this is that you don't need high levels of water, whereas perhaps you might want to run with 150 litres per hectare without it. With this material added, you could probably run at 100 or even less litres per hectare. So it speeds up the work rate. You can see the odd little area where it hasn't covered the leaf, but predominantly 90% of the leaf has been covered with the spray.